okay? Is it recording? Okay. Where's it flickering? My computer's going haywire lately. So topic 4, Ka, Kb, and Kw. What's important about K? Products over reactants. It's K. Ka is equal to products over reactants. So is Kb. What's the difference between Ka and Kb? A is for acid, B is for base. Mathematically, though, no difference. Right? But the third one is Kw. And W stands for water. And water is special because it's equivalent to the hydronium ion concentration and multiplied by the hydroxide ion concentration. And those two values, when combined, will always equal 1 times 10 to the negative 14. Okay? Hi, Alan. Just Alan. Jeez, that's not nice. Hi, Alan. I know you weren't. Okay. Good. What I have written here, I can't read what I wrote. Oh, what do we include and what don't we include when we do Ka, Kb, or Kw? Just like K, right? Okay. So we include aqueous and gas. Remember that H3O plus is aqueous and H2O is liquid. So which one would we include? H3O plus is yay. Liquid is no. Okay. So consider a sample of stomach contents with a pH of 1.40. Not a morning question for me personally. What? This is bio all over again. We do use the quadratic for the Harry Weinberg. We just use it once. That's the only real math. I guess we do phenotypes and genotypes. We remember that, right? Grade 9, we have to calculate out of 100%. Okay. So finding H3O plus concentration and OH negative concentration. So what do we know? We know one thing, and what is that? The pH. What can we do with the pH? Yep. So you can convert the pH into, you could, we don't need POH, right? You can convert it into hydronium ion concentration by taking the anti-log of negative pH. So once you get the hydronium ion concentration, 10 negative 1.40, that ends up being H3 plus is equivalent to 3.98 times 10 to the negative 2 mole per liter. Now we know the relationship between Kw is equal to 1 times 10 to the negative 14. And we know that's equal to the hydronium ion concentration multiplied by the hydroxide ion concentration. So we have this one. That one was easy to find. What can I do with this to find OH negative? Starts with an S. Substitute, right? So I know I have 1 times 10 to the negative 14 is equivalent to 3.98 times 10 to the negative 2 mole per liter, and multiplied by OH negative. Take 0.98 and divide by both sides to remove. 8 times 10 to the negative 2. That cancels, and OH negative will equal, where am I here? Calculator was. Oh, there we are. 2.51 times 10 to the negative 13 mole per liter. That's my answer. Is this solution acidic, basic, or neutral? It's acidic, good. pH is no. Another way you could look at it is to look at the concentration. So 3.98 times 10 to the negative 2 is larger than 2.51 times 10 to the negative 13. So the hydroxide concentration is higher, or pardon me, the hydronium ions concentration is higher than the hydroxide ion concentration, which would make it acidic versus basic. Okay. Are we good? Am I too fast? Moving? Complaining? No. Okay. Blah, blah, blah. What is the hydronium ion concentration? 0.1 solution, KHSO4. If Ka is given. Ka is given, what should I automatically think to do? Rice table. I heard you. Okay, what do I do for the rice table here? What do I know I have? If I have given Ka, what is Ka for? An acid. Okay, so I know that this is going to behave as an acid. Okay, and with acids, we usually put them in, well, they're in aqueous solutions, so what's there? Water. Liquid, right? We know since Ka is not very large, but it's not very small either, that it would be at some sort of equilibrium and not 100% dissociation. So what would happen? We get a hydronium ion, good. And what would be left over? Why is it all SO4 negative? Oh, can you hear me without it? Yeah. Jake? Yeah. Okay, I. What do I know about I? 0.100 mole per liter. Liquids we don't worry about, and these two should start at 0. Change. What do I know about my change? It should be negative x, and this should be positive x and positive x. I assume that it's balanced. Always make sure that it's balanced. I should say that. And what do we got? A line. 0.100 minus x, x, and x. And we'll put the s there for later, right? Okay, now I need something to substitute into. Then I write my Ka expression. My Ka is equal to products over reactants. My products are my hydronium ion multiplied by and divided by H. Oops, K was first, right? HSO4. Right? Yes, no, good? Yep. Okay, from here, what would I do? Substitute, right? So Ka, my value is 1.2 times 10 to the negative 2. Hydronium ion is x. KSO4 negative is x. And bottom should be 0.100 minus x. I can't ignore x because, well, Ka is just not fitting my parameters. Ignoring, right? So then I just simplify and clean it up, right? So 1.2 times 10 to negative 2, 0.100 minus x is equivalent to x squared on that side. Distribute into the binomial. And what do I get? 10 to the negative 3 minus 1.2 times 10 to the negative 2x. And then I'm going to move x squared over to equal 0. Can x squared be negative? Yeah. I know your teachers might not like that, but it works. And if you want me to rewrite it, you want me to rewrite it or you're good? Can you pull your values? So A is negative 1, B is negative 1.2 times 10 to the negative 2, and my C value for my quadratic is 1.2 times 10 to the negative 3. Right? So once I get my values, what do I then have to do? Quadratic. Do we need another example of quadratic, or we're comfortable? Okay. Quadratic. and you know what it is. A, and you're going to get a value of 2.92 times 10 to the negative 2 mole per liter. Okay. Okay. After that, what do? Substitute back in. This number goes all the way back here. And really the question is only asking for the hydronium ion concentration. So I technically only have to state that, right? That would be my final answer. That's it for acids and bases. So I can't say that one unit is worth more than another on the exam. That's equivalent. So some units, though, have more multiple choice than others. So that might be different. Some of the multiple choice does require work. So if you want to bring extra paper, I can provide scrap paper for you to work on. That would also be something that you'd want to do. The exam usually takes between 2 to 3 hours. I've never had, well, probably had people get close to the 3, but not right over. But we are in the morning, so you shouldn't need more than 3 hours. So it should be done. So there is a sheet to fill out with your multiple choice, so make sure you fill that out correctly. And don't look, every year I get someone saying this to me, oh, it would never be 3 A answers in a row. Teachers don't do that. I'm like, don't look for that pattern. Like just, right? It's D's. No, it's 3. I think it's 3 D's in a row. And then there's this silly little question that, yeah, anyway. So, yeah, no, it's not the scuba question. So, it'll be, yeah. Okay. Oh, this K is always capitalized. The rate log K is lowercase. Yeah. Yeah. All right. So let's review last unit quickly. So everybody needs some sort of definitions. Why is my cursor blinking? So an anode is the oxidation half cell where oxidation occurs, your Leo or your oil, right? The cathode is the opposite where reduction occurs, right? Isn't this in your booklet? I didn't put number 6 in your booklet? Yeah, I know. That was for you to do. Well, if you want to. I don't think I could make these any shorter. Well, anode could just be oxidation half cell. Cathode could be reduction half cell. Oxidation, Leo. Yeah, I could definitely shorthand it. I was laughing. I was looking at bio stuff. Then we get into the bio or the evolution. Remember we watched that video and it was a grade 9 and grade 10, the Scubasaurus or whatever. I was laughing when I saw. Oh no, we're gonna have to go through that again. And you figure out the evolutionary path to human Homo sapiens. Pardon? Not everyone's in bio. I looked. It's Probably easier to ask who isn't in bio. It's completely different than 11. There's two big things, is genetics and biodiversity. So within genetics, we do like Mendelian genetics, non-Mendelian genetics. We have a bit more complicated punnets. And we also talk about DNA synthesis. Have you ever extracted DNA from strawberries or onions? Yeah? You have? Yeah? So do that. And then there's evolutionary theory. And then there's classification systems, which are really big in biology. And then conservation of biodiversity is the last part. I don't know if we'll get to that. Can I move it up a bit? No, it's all there. Yeah, this unit's 14 marks on the exam. Every other unit is between 24 to 20. Yeah, 138? Yeah. I would have to know the answers. What are the names of Braden's dogs? I still don't know those either. I know Scoops. Well, Ghost Rider. Ghost Rider. Like the Nicolas Cage movie Ghost Rider? Right. That movie's PG. Yeah. No, it's something I could show to my son. Nothing like Deadpool, that's for sure. When you're old enough to watch Deadpool. Is there a second one?
The second one's a family movie.
Oh, we watched the family one, Once Upon a Deadpool. You seen that one? They made a PG one. Yeah, we bought it because my kids wanted to see Deadpool. We're like, ah, no. You can watch this one. He captures Fred Savage and he locks him up in a basement. And he tells him the story. So it goes through the movie pretty edited. Yeah. I think it's the second one where he's trying to become an X-Man. Sort of X. Yeah. Yeah. Are the X-Men not in the Marvel universe? No, not yet. I mean, yeah. Chloe looks at me like I should know this. Yeah. I don't know why they're not though. Are we done? I watched the Eternals though. I didn't think that was that great. No. But Boba Fett, the Mandal. Yeah, I don't want to ruin it for anybody. Isn't what? Boba Fett? Where's Harry Styles in Eternals?
I know.
What? Where is he in there? I didn't see him. Really? Yes, I watched the post. I did not know. I did not recognize Ben. I might have to go back and rewatch that then. Okay. Oh, sorry. Where are you at? Okay. It is online. Regi? Okay. So voltaic cell has two parts, right? An oxidation half cell and a reduction half cell. Electrons flow out of the anode and into the cathode. You need to be able to identify. You need to be able to label. I spelled label wrong. And you need to be able to calculate. So does everybody have their standard reduction tables available for the exam? Okay, so make sure you bring that in. Okay? If we don't, it's online, and I did post the link. It's page 5. Yeah. Maybe? Maybe.
So we can make sure.
Oh, it's gonna take me a while. Okay. Yeah, so know that they flow out of the anode into the cathode, or they flow from oxidation to reduction. No. No, there's no labeling. Maybe next year. Can I go on? No flow of electrons. That's what that's supposed to say. Okay? No, the flow of electrons. So no, they flow. I said it, this is my 3rd time now. Out of the anode into the cathode, or oxidation to reduction is the flow of electrons. Okay? Can I go on? All right, reduction potential. Determine which half reaction is reduced and which is oxidized. Write the standard notation form. Okay, so if you were given 2 half reactions, how do you figure out which one's reduced and which one's oxidized? You remember? They're both written that way. Yeah. So you would use the cool. I didn't realize there was that. The chart. Right? So which half reaction is higher up the chart is the reaction that is reduced. The higher up the chart, it's reduced. The chart even says that, I believe, in an arrow. Yeah. Okay. So if the half appears at the top of the chart or near the top or higher up than the other reaction, that is the reaction that's reduced. Okay. So since copper is higher up on the chart than sodium, copper is reduced. Okay? When you then look at what's oxidized, you have to switch that half reaction the way it's written to make it look like it is losing instead of gaining. Because everything on that chart looks like it's being reduced. Okay? So everything has the ability to be reduced, but when it's paired with something, the flow of electrons will favor the half reaction that's higher up on the chart. Then you have to switch it. Okay. And then the standard notation is always the anode first and then the cathode. No coefficients. Correct. Good answer. Good question. All right. May I go on? Okay. What is the voltage produced by a galvanic cell consisting of aluminum electrode in contact with a solution of aluminum ions and an iron electrode in contact with a solution of iron 2 ions? Which is the anode and which is the cathode? Okay, so to answer that, I go on the chart. Okay, I look at iron 2 is higher up on the chart than aluminum, so iron 2 becomes my reduced half reaction, which is then automatically my cathode. My anode is my oxidized. I like remembering it because these are both vowels. So the anode is always oxidized because A and O are vowels. That's how I remember how to pair those two together, and then the other two just because there's nothing else to pair with, right? Okay. So I'm not writing any sort of overall reaction here, so I don't have to worry about bouncing. I'm just calculating. So everybody has this hopefully written down somewhere on a cheat sheet, or will have it written down on their cheat sheet. When is our exam again? Wednesday? Okay, I have it written on the desk next door. Wednesday morning. We'll be writing in this room. We'll be spread out. The desks hopefully won't look like that by then. Yeah. Stack you like sardines. I don't know, is it restricting the airflow?
I mean, all different levels, right?
Ventilation on. Okay. We're good? Confident we can do this? Questionable. And this question is similar, not similar, it's exactly like it is on the exam. Okay, so you have the term, and I even showed you it on your like your little assessment you did when we came back from remote learning. So given the following pair of voltaic electrodes immersed in their metallic salt solutions, you have 4 things you need to do. Number 1, identify the anode and the cathode. How do you do that? That's the chart. Write the 2 half reactions. Remember to flip the anode. Okay? Write the overall net. So that's when I stack the 2 half reactions. This one's fine because there's 2 electrons on each side, so they can both cancel. And make sure the electrons are on opposite sides to cancel. Right? Okay, and the overall is written by what's left over, just like we did with regular redox. And then number 4, Roman numeral 4, is your standard potential. Remember that 2 negatives make a positive. Please. That's debatable. I'm kidding. I don't know. I'm trying to think now in my experience. 2 wrongs ever made a right.
Self-defense.
Laws are very different in Canada. All right. Okay, so I would really probably have this example on my cheat sheet. Yes. Okay. What? Yes. And you always flip the anode. Make it look like it's losing electrons. Say again? That's irrelevant. Yeah, irrelevant. I think if you put, yeah.
As long as you put together.
Yeah. As long as you stack them and cross out the electrons and write what's left over, you're good.
Find out the folder, though. Like,
Mhm.
like the like elements, folder.
Yeah, the two half reactions on the chart.
Yeah.
Yeah, and then take their values and take the difference. And that's what you should get. If we hook this up in real life, okay, can I move on? Okay. So some sort of idea of where this happens in your life. Your phones, in fuel cells, in electroplating, making jewelry, the batteries that run almost everything you own. Corrosion is an example of reduction, and galvanization of pipes, for example. Okay. That's it. So questions, comments?